Welcome to Introduction to Kubernetes. After watching this video, you will be able to define Kubernetes, explain what Kubernetes is not, relate Kubernetes concepts, describe Kubernetes capabilities, and describe the Kubernetes ecosystem. The official Kubernetes documentation describes Kubernetes as an open source system for automating deployment, scaling, and management of containerized applications. Kubernetes is widely available and has positioned itself as the de facto choice for container orchestration. Kubernetes is an open-source containerization orchestration platform developed as a project by Google and is currently maintained by the Cloud Native Computing Foundation. It is easily portable across clouds and on-premises. With its growing ecosystem of projects and products by both member and non-member partners, Kubernetes is recognized as the go-to container orchestration solution. Kubernetes as a service grew as an extension of Containers as a Service. Kubernetes facilitates declarative management, in which it automatically performs the necessary operations towards achieving the called-for state. Here is what Kubernetes is not. It is not a traditional all-inclusive platform as a service. It is not rigid or opinionated, but more of a flexible model that supports an extremely diverse variety of workloads, including stateless, stateful, and data processing workloads. It can work with all applications that can be containerized. It does not provide continuous integration, continuous delivery pipelines to build applications or deploy source code. It does not prescribe logging, monitoring, and alerting solutions. Organizations are free to select and integrate third-party and open-source tools. And it does not provide built-in middleware, databases, or other services. Let's check out some Kubernetes concepts. Concepts of Kubernetes include the following. Pods represent the smallest deployable compute object and the higher-level abstractions to run workloads. Services expose applications running on sets of pods. Each pod is assigned a unique IP address, and sets of pods have a single DNS name. Kubernetes supports both persistent and temporary storage for pods. Configuration, which refers to the provisioning of resources for configuring pods. Security measures for cloud-native workloads, which enforce security for pod and API access. Policies for groups of resources, ensuring that pods match to nodes so that the kubelet can find them and run the pods. Scheduling and eviction that runs and proactively terminates one or more pods on resource-starved nodes. Preemption, which is all about prioritization. Preemption terminates lower priority pods so that pods with higher priority can schedule and run on nodes. And finally, cluster administration provides the details necessary to create or administer a cluster. Kubernetes capabilities include automated rollouts of changes to application or configuration, health monitoring, and rolling back changes. Storage orchestration that mounts a chosen storage system, including local storage, network storage, or public cloud. And horizontal scaling of workloads based on metrics or via commands. Additional capabilities include the following. Automated bin packing that increases utilization and cost saving using a mix of critical and best effort workloads. Automated bin packing performs container auto placement based on resource requirements and conditions without sacrificing high availability. Kubernetes includes secret and configuration management of sensitive information, including passwords, OAuth tokens, and SSH keys, and handles deployments and updates to secrets and configuration without rebuilding images. And Kubernetes assigns both IPv4 and IPv6 addresses to pods and services. Kubernetes manages batch and continuous integration workloads and automatically replaces failed containers. It self-heals failing or unresponsive containers. It discovers pods using IP addresses or a DNS name, and load balances traffic for better performance and high availability. And Kubernetes adds features to your cluster without modifying source code. The Kubernetes ecosystem is a large, rapidly growing ecosystem where its services, support, and tools are widely available. Running containerized applications requires separate tools in addition to the Kubernetes orchestration tool. The ecosystem includes services like building container images, storing images in a container registry, application logging and monitoring, and CI/CD capabilities. The Kubernetes ecosystem is a huge collection of products, services, and providers. Leading public cloud providers include Prisma, IBM, Google, and AWS. Open source framework providers include Red Hat, VMware, SUSE, Mesosphere, Docker, and Cloud Foundry. Management providers include DigitalOcean, Loadsea, Supergiant, Cloudsoft, Turbonomic, Tectonic, and Weaverworks. Tool providers include JFrog, Univa, AspenMesh, Bitnami, and Cloud66. Monitoring and logging providers include Sumo Logic, Datadog, New Relic, Iguazio, Grafana SignalFX, Sysdig, and Dynatrans. Security providers include GuardCore, Black Duck, Yubico, Cilium, Aqua, Twistlock, and Alcide. And load balancing providers include AVI Networks, VMware, and NGINX. In this video, you learned that Kubernetes is a highly portable, horizontally scalable, open-source container orchestration system with automated deployment and simplified management capabilities. Its concepts include pods and workloads, services, storage, configuration, security, policies, scheduling and eviction, preemption, and administration. You also learned Kubernetes capabilities include automated rollouts and rollbacks, storage orchestration, horizontal scaling, automated bin packing, secret and configuration management, IPv4, IPv6 dual stack support, batch execution, self-healing, service discovery and load balancing, and finally, designed for extensibility. And the Kubernetes ecosystem includes public cloud providers, frameworks, management, tools, monitoring and logging, security, and load balancing.